So today, I want to take you through those new sections, and basically my idea is to show you what they look like. It's not so important for me to show you what the content is, because the words themselves will change project to project. Your project can't have the same words as the model projects, but they can basically look the same, and that's going to help you to direct your teammates to have the right content. So here's where we are. Right now, you're heading toward, you've got your CDS coming in this week. Finally, they'll all be in by Saturday. And then they'll come back from the TA, go through the approval process, the revision for the PM, the approval process of the PM, and then you'll have your third and final client meeting. The purpose of the client meeting is to determine the design that you're going to write about in your final design specification. So you're going to have to do that fairly swiftly, since the final design specification is due in week 13. So that's coming up pretty rapidly. The final design specification incorporates a lot of research, because what you're doing in this document is you're telling the client as much as possible, as much good detail as possible, about the implementation of the design that you and the client have agreed upon looks like they can implement. So there is a way of determining quality of research. It's called the CRAP method, C-R-A-A-P. And it is a way of preventing your document from having crap, C-R-A-P, in it. And that's important because your mark is going to depend on that. One of the things that you have to watch for, and you may have already caught this in your project requirements and conceptual design specification, because this is something you've got to deal with in your team, is when people want to make a claim, they come up with the claim, and then they find any old thing on the web that might possibly back up the claim, they slap in the number, and they slap on the reference. And lo and behold, your TAs, you know, it isn't that they're so fastidious they check all 67 references, but they are intuitive. And they can see it or feel it, and they will spot check, and they have come up with why does this reference, you know, even I kind of going through drafts, I'll find these references and I'll write a comment like, oh, the reference doesn't match the claim. So number one, claims don't come first. Research comes first, and claims come out of research. Number two, the research must be in better sources than Wikipedia. Wikipedia is a good place to start, but Wikipedia is not an academically rigorous source. There is plenty of plagiarism within Wikipedia, so Wikipedia is a kind of dangerous place to go to rely on. It's a good place to take off from. So what you're looking for is currency. How up-to-date is this information? This is engineering. You know, I'm a theater historian. Up-to-date for me means, you know, 1752 is a good date. You know, 1642 is a good date. Something from then. That's what I look at. But that's not engineering. Engineering is up-to-date. The technologies change rapidly. You should know what's going on now. Currency is important. Is it relevant? Using a reference from the United States EPA, the Environmental Protection Agency, while it still exists before it's destroyed, using that as a reference for Canadian regulations is irrelevant. Our regulations are different, and you have to use the correct source, not the source that comes up quickly on Google. Google's an American product. It'll bring up American sources before Canadian. Canada's a little wee country with not a lot of power. And so you don't get a lot of Canada hits. So you've got to go look for them, because the EPA is not going to come in here and regulate our environment. They're going to happily ignore it as multinational corporations do what they want to it. But our environmental protection regulations will try to protect it sometimes. Authority. Is it a real authority? Now, authority is not a yes-no. It's not a binary. There is no longer, in the world that we live in, a specific, unquestionable authority. Authority is contextual to the information that you're using. So, a car manufacturer, an automobile manufacturer, is highly authoritative in relation to the specifications of the automobile. They are not authoritative in terms of the performance of the automobile. Volkswagen can be trusted to tell you that they have installed an emission control device. They cannot be trusted to tell you that it works. We know that. And so, when you're looking at a source, it is your purpose for using the information that determines the authority of the source, not some outside credential. So you could have, like, the most authoritative professor in the world, but if you ask that professor, or if that professor is writing about something they don't know anything about, like pronouns, then they're not very authoritative. And so the authority is contextual, and you've got to figure that out. Is it accurate? Well, we look at more than one source usually to determine accuracy. That's why we ask for more than one source for claims. It's a good test for accuracy. Finally, purpose. Oops. It's not going to do this, is it? Oh, now it's yellow. Okay, purpose. Why is the source giving the information? Question 1. Why are you using it? Question 2. It is when you clarify the change between the purpose of the source and your purpose that you understand how to paraphrase. Paraphrase is not changing a word here or a word there, as people have learned from really horrible plagiarism meetings. Paraphrase is changing the nature of the purpose of the information so that it is actually expressing something you want to express and not expressing something that the source wants to express. When we express something, we are trying to do something. And you have to ask yourself, in this section like an introduction, what am I trying to do? And I'll talk a little bit more about that later. But determining what was the source trying to do and what do I want to do with it will really help you to put it in your own words. Finally, last words on research. The good news is that research in engineering is not about going into the library, going into a study carrel, piling up a bunch of books, pulling out a bunch of almost impossible to read journal articles, and spending hours and hours being so bored that you feel like your skin is falling off. Engineering research has to be as efficient as everything else in engineering, and it uses engineering research sources. So here are a few examples. If you're going to access mechanical parts, tools, or raw materials, go to McMaster Carr. McMaster Carr is where engineers go. And that's where you're going to get the actual wholesale prices, not the retail prices. We're not interested in having our clients buy retail when they can buy from McMaster Carr. If you're trying to estimate construction, RS Means does a lot of that work for you. It does it on an annual basis, and it uses a lot more data than you have access to. So going to RS Means is faster. RS means online, if you go there in your bedroom, is going to cost money. RS means online, if you go there in the library, is free. So with both McMaster-Carr, RS means DigiKey with all of these things. And if there is no engineering source that you can think of for what you need to find out, go to the second floor of the Sanford Fleming building, go into the library and talk to a librarian and ask them to help you find something that will give you clear information quickly. And that information is not in long, dense paragraphs that are hideous to read. It is in tables and other things that just give you the information. Your turn. So now it's time for a question. Okay. So which stakeholder interests would help a team designing an entry ramp system for a Southern Ontario highway to make design decisions? The stakeholder of drivers who want faster entry onto the highway, the stakeholder of police whose interest is obey all laws on entry ramp, SOCAR, the Southern Ontario Centre for Aerosol, I was going to get the whole meaning of that one, but it's aerosol research, aerosol and particulate research in the air. Their interest is increased awareness about the impacts of air quality on human health, or the Ministry of Transport, cost of entry system. Pretty easy question. Now, 43 of you? That's such a sad number. A is incorrect because drivers are users. B is incorrect because it's totally design-driven. And police may be interested in obey all laws, but they're not thinking about that particular entry ramp at all. You're thinking about that entry ramp. Oops, 110 people have managed to change their vote. SOCAR has an interest that will relate to design decisions. Cars idling on an entry ramp contribute to particulate matter in the air. So, and the Ministry of Transport, cost of an entry system doesn't, that again is totally design driven. So again, for the quiz, note, every single incorrect answer repeated the question. Every single incorrect answer had the word entry or entry ramp in it. It referred back to the question and the design. So the old rule of repeat the question in your answer does not hold with stakeholder interests. Stakeholder interests are independent of the design. Somebody asked, can you explain again what authority means? And that's a really great question, because we used to think of authority as, just the person most powerful in any situation. The most established engineer in a field is the authority on that form of engineering. And that's sort of a true definition. But now, authority is the basis on which we can trust the information. And the reason for the change in that definition is because of the massive amount of information that is useful and is coming democratically at us through the web. People who are writing on the web will establish their authority within the first few sentences of a review or a blog. So a good example is for reviews of cameras. Someone will establish their credibility or establish their authority by talking about their relationship with cameras. I have been a photographer for 15 years. I am an amateur photographer. I have always used Canon cameras, but now I am using Nikon cameras. These sentences establish the authority of the information because they tell you on what basis it's made and what the bias is. If it's a negative review of Nikons from a Canon user, then you understand the bias. But if it's a positive review of Nikon cameras from a former Canon user, then it will have a different kind of authority. Authority, like everything else in our life today, is no longer a firmly bounded idea. It is now flexible and something to interpret and understand. I wish I could give you a much easier definition that was just, here it is, blank, here's what authority is, but unfortunately, it doesn't have that kind of solidity. Here is the required content list for the FDS. You can see that it looks much the same in the PR as it always has. The old 2.0 section from the CDS, which had your alternate designs, is completely gone, and there is now a new 2.0 section with all these new sections in it that you haven't seen before and you haven't had to do before. So let's see what they look like and what they've looked like in some examples. 2.0 is a lot like 3.0 from your CDS. And if your client actually approves your recommended design, your 3.0 from your CDS can really contribute to this. Now, it can be a very long section. If you have multiple components in your design, it will be a long section. Because this section tells, first of all, why does the design meet the client want? It's got that argument that justifies the design, and that's supported with evidence. And then it goes through the details of how does the design work. If it's multi-component, you're really going to want to break that down into multiple subsections of 2.0. And that's going to change things a lot. But those multiple sections, they may be 2.0.1 or 2.1 and change all the other numbering. You're going to have to talk to your TA about the best way to number this once you break it into subsections. So I'm giving you an example. It says here, make sure that the subsections are unique to your document, to your project, and not just lifted. But the example that I have is a single, this is a single component detailed design. And I know that you can't read it very well, but I decided that that's kind of okay, because you're not going to be writing the same thing as this team wrote. They were patching a concrete canoe, and they talk about why they're using thermoset plastic instead of thermoplastic, which is the original, one of the original materials of the concrete canoe. So they have a paragraph where they justify it, and then they describe kind of how the epoxy works, and then they have a table showing how this design meets the functions, objectives, and constraints. And one, you know, they have the objective, lightweight. They have the metric, where they define the density, you know, in numeric terms. So we don't really like people behind the screen, thanks. And then they have how this design compares with the metric. And that table continues. That's what it looks like. And then they have this series of figures that go through, you know, from the actual damage in the canoe to what does the surface look like when it's sanded and prepared to, you know, what does it look like when it's curing. This is one example of a 3.0. What I like about this example is it shows there is a description, there's a table, and there are figures. It's a relatively simple project in that it only has one component. There's only one crack, and they're only focusing on that. If you're focusing on multiple components, then you're going to have to do this several times. 2.1. Regulations, standards, and intellectual property. So this is where this is the due diligence section. Like, what does your client need to know? You know, if you're designing a deck for your client and you say, you know, this deck, you can just do it yourself. It's the do-it-yourself deck. You go and you get all the material from Home Depot, and you don't tell your client that despite the fact that it's a do-it-yourself project, it actually needs a building permit, then you're not doing due diligence. Maybe it doesn't need a permit, and you have to find that out for your client, and so that your client doesn't have to waste their time trying to file for a permit that they don't need. This is one of the sections where you create added value for your client because you're doing the research that shortens the time for their implementation. So, what does it look like? Here's an example from, and there's a problem with this example that I'll talk about in a minute. But this is an example that has a little introduction. The products used by our design are materials that can be purchased off the shelf, and so they're patented. Health and safety regulations that are important for our design are outlined in the table below. And again, they have a nice table with the regulation on one side and a description of the regulation on the other side. Very, very nice. I'm not going to show you the whole table, but I do want to draw your attention to a little piece of real bad writing. Patents are not important to our design. What they really mean is, because these are off the shelf and are purchased, all licensing fees are incorporated in the purchase price, and so you don't need to worry. These are licensed products. Saying that they are not important to us is actually not true. They are important. And you know, this comes back to, how does your document hold together? Now, if you're doing your document for a client who is like perhaps Professor Courtshot, who is an inventor for whom intellectual property is vitally important, and you say patents are not important, you know, they're going to understand what you mean, but it's going to give them pause. They're going to go, oh, no, and you're going to go into your client meeting, and your client's going to kind of have a word with you about that. And clients are not always, like some client meetings go really, really well, and everybody's really friendly, and everything goes well, but sometimes clients, as some of you have found out, they can be kind of difficult. You don't want to have a difficulty around a negative. So the word not comes very easily to us, especially in situations like this. But in good engineering writing, you don't put it in, you actually reverse that. What does this really mean without the negative? It means that all patents and licensing fees have been paid. I would rather hear from a design group that all licensing and patenting fees have been paid than these are not important. Because these are not important is a value judgment, and these have been paid is a fact. Testing. So this is a testing section. I don't think you've done like a true testing section before. And I'm about to contradict myself and be really confusing, so bear with me. This slide starts with the words, ESP teams are rarely called upon to perform the tests themselves. And that is true with the word rarely being emphasized. You do not have to perform these tests. That's not a requirement. It's not in the scope of this document. But the reason that I emphasize it is because the tests that you name should be real tests. They shouldn't be tests you make up. So no surveys and stuff like that, like forget it. How do real engineers really test? And I know you're going to say, well, it's hard to test usability, or it's hard to test aesthetics. Well, it's not. Engineers can do it. They define it in a measurable way, and they test something measurable. You want it to be aesthetically pleasing? Well, you've got to define aesthetically pleasing for an engineer. Engineering definitions of aesthetics are available online. You just Google engineering and aesthetics, and you will find aesthetic features like form follows function, minimal mass for supporting the load. Look at your iPad, look at your computer, look how thin it is. It is tested so that its thinness can perform its jobs, and that makes it aesthetic. And so you can find the tests that are used. Also, because there's a separate section on environmental factors, environmental tests don't have to be included here. They're dealt with elsewhere. So here's the example. Here's where I contradict myself. Lightweight and durable are two top objectives. In order to ensure our design meet the objectives, our team plans to carry out the following standard tests to measure density, flexural strength, and bonding strength of the concrete epoxy mixture. Since safety and environmental measures are discussed, they will not be presented. Now, I said you don't have to, and I actually don't, in fact, know. I could ask the students if they did do these tests, but the reason that I decided to keep it is because their test table is really lovely. It's really, really nice. They give the objective. They talk about what the objective measures. Lightweight is the objective. It measures density, which is the ability to float on water. Here's the standard test, comes from ASTM, and then they describe the procedure. One of the things about your testing section is that the TAs do not want to just see a standard. They don't want it to stop before that last column. So lightweight, density, ASTM D189, that's not enough. The procedure, that addition is what got these guys their A. And that's what you've got to have. The TA may decide to look at the standard and find that procedure out of their own interest, but in fact, these guys have done a really good job of showing the objective, how it's measured, and then describing the test. Is the FDS an entirely new document, or is it added on top of the CDS? That's a good question. It's not an entirely new document. The alternative design section 2.0, the 2.0 sections, those are removed. 3.0, if it's been approved, comes up and becomes 2.0. If it hasn't been approved, then one of the 2.1 to 2.5 sections becomes 3.0, whichever has been approved by the client. I don't understand how the design of a ramp could impact air quality at all. There's no relation. Cars idling on a ramp produce more air pollution than cars moving forward. The pollutant that cars emit may contain particulate matter that is extremely, extremely tiny and extremely dangerous for health. So if you create a ramp that allows more flow through, you create a ramp that diminishes air pollution. That's how the ramp affects air quality. Implementation requirements. So what is going to happen to your client if they decide to implement this particular project? If you walk through the basement of the Galbraith building, something I do all the time to get to the men's room, you'll see that where all the lockers were, they've been moved to another hallway. That's an implementation requirement. What is going to happen is that whole hallway is going to be rebuilt. The first thing is that all of the lockers had to be moved. All of the concrete samples from within the concrete lab had to be moved. These are implementation requirements. What are the steps that your client is going to have to take in order to implement? What are the costs that your client is going to have to bear? What are the capital costs? Are people going to have to be hired? Are people going to have to be laid off? What is going to happen? You know, do stores have to be consulted or informed? You'll notice that one of the implementation requirements of infrastructure change is that residents in the affected area have to be informed that there will be work done on their street. If your street is lucky enough to have a Hollywood film being filmed on it, then you're going to get those notices. Those are all part of implementation requirements. What does your client need to know? In this case, the implementation requirements for patching a concrete canoe, are relatively simple. There's some purchasing that has to be done. There's some data that has to be collected. And then they have to make sure that the setup is in a ventilated room and prepare the crack and then mix the epoxy correctly. And so that's kind of basically it. Again, as a model, this is relatively simple. So it's a good model because you can see the shape of the implementation requirements. But your project may take many more implementation requirements or very different implementation requirements. Life cycle. Now, for life cycle, I think it's really important that you go back and review the life cycle modules in the textbook so that your life cycle analysis is really both comprehensive enough but relevant enough to your particular document to be useful to the client. You know, if you're designing a birdhouse that is a one-off in back of somebody's house, well, you know, maybe it's not going to add to global warming significantly, but you should know some things about it. So here's what it actually looked like in one document. This section is a life cycle assessment to show the design's creation to application process. The scope is limited to basic materials directly related to the design, excluding the processes involved with the synthesis of these materials. Table 8, which I'm going to show you in a minute, highlights the positive and negative environmental impacts and feasible techniques. So here you have the life cycle diagram, and in the introduction, they give the scope of the life cycle analysis. Okay, so, and here's the table where they talk about the environmental impact, they give the details, and they also provide mitigation techniques. So it's not enough to say, you know, that this ramp and stopping traffic is going to add to air pollution. You also have to add mitigation techniques. Trees will be planted along the perimeter of the ramp. Trees are very helpful in this matter, whatever. So it's time for a question. Here's a sign from a Presto machine. It says, please leave Presto card in a holder until screen says take Presto card. This is an example of A, intuitive design, B, user-centered design, C, universal design, D, failed human factors design. I have seen far too many times that people have written next to simple to use, simple instructions. Instructions of any sort mean that the design is not intuitive, it needs instructions. That's by definition. Intuitive design needs no instructions. It's so simple or familiar, we do it without instruction. A lot of what you're used to now is intuitive design. You're not very used to instructions. I don't know if you have a Presto card or tried to reload it at a subway station, but 90% of the time before this sign was put on that machine, people would remove their card after it was loaded. But then that would cancel the transaction because the transaction takes a little bit of time. User-centered design utilizes feedback to tell the user what is happening, and the machine gave no feedback. So you get the feedback that you know, the design was, that you know, you could remove your debit card, but you didn't get any feedback that you couldn't remove your Presto card. So you'd remove your Presto card and pff, transaction canceled. I imagine there were a few complaints. And so suddenly, these signs appeared. please leave your card in until we finally give you that information, because we can't figure out how to do a little circle that's going around and around that would intuitively tell us that something's going on, don't remove your card. Or even, don't remove your card yet. So it's not intuitive, it's not user-centered, because certainly they didn't ask the users or watch the users to determine what goes wrong when people try to use an automatic machine. And actually, universal design, had I shown more of where the machine is, universal design would have been closer to the truth. Because again, if you've tried to use them, you have to kind of, get down on your knees and look in. And that's because I'm not in a wheelchair. And if I was in a wheelchair, it would have been, it is kind of perfectly located for me. So they were trying to incorporate universal design, but not user-centered design. And I'm glad I asked that, because it means that now you know that when you are answering the questions in human factors, don't just slap in user-centered design because you think, oh, that's the right answer. If you haven't used user-centered design, then you haven't used it. It's not there. Here is a graph that shows user-centered design. And I believe that graph, I reproduced it also in the handout, because it comes from a published source. And this shows where the user feedback was integrated in the design process. User-centered design uses the user as part of the design process. That's what it does. So go back and reread or read the human factors sections when you're doing this section and answer these questions. How are you incorporating human factors into this design? Social impact is by far the most difficult of all of the sections, especially for small one-off designs that don't affect very many people. One of the things we've done in order to help you write a good section is we've suggested that you try to balance stakeholder interests. You go back to your stakeholder section and you say, okay, it does this and that really helps. So you can see here, this is a typical social impact section, and it talks about the social impact of this particular design. In this case, it was a design to help people renovate in order to get off the grid. And so they say, well, that's a social impact, because if it's successful, more people will get off the grid, and that will make energy needs more sustainable through the years. And so, it's pretty good. My advice on social impact, I have two pieces of advice for the person writing that section. One, make it short. And two, make sure you talk to your TA and find out, how does your TA feel about that section? Economics is going to take into account a lot of the lectures that you've gotten. You've got some economics lectures from Professor O'Brien, but you get a lot more from Professor Anderson, and it takes those into account. Economics is a table that looks at capital costs, ongoing costs, fixed and variable costs, disposal and decommissioning costs, and it also notices, while it doesn't quantify, external costs. So these are 5 definitions. Word to the wise, because it may be on the quiz. Well, certainly, economics questions will be on the quiz. Make sure you know what a capital cost is, and you know the difference between a capital cost and an ongoing cost. That one doesn't trip people up as much as the difference between a fixed cost and a variable cost. Is rent a fixed cost or a variable cost? Is it fixed or variable? Just shout it out. Yes, fixed. Even though it goes up sometimes, it remains constant. It doesn't fluctuate. Good. And here's what an economics section looks like. This one's kind of a nice one. Your PM is a real good guide on how to do an economics section. They may tell you kind of all these different things about doing spreadsheets, and they're very useful, or where you should put the labels. These guys have got it down one side. Some people would prefer them across the top. Talk to your PM and get that information. But you can see the kind of cost is noted, and the nature of the cost is noted, and then the cost is noted, and the total cost is noted. And remember, when you go to the total costs, cents go to only 2 decimal places. Your calculator will give you more than 2 decimal places, but nobody wants to see those. Finally, in some cases, but not all, the client has said they're interested in scaling up, that they're interested in manufacture or distribution. And so if that is the case, you will want to provide value to your client by incorporating a market issues section. A market issues is what it sounds like. It looks at what currently exists on the market, where is the market niche, why would this work, who would buy it, what are they currently buying, what are their needs. And so it'll also incorporate some, what is the time to market, like, you can figure out something to market, but it may take so long to develop that by the time it gets to market, there'll be substitutes that do that job better. So this section, and you've got the notes from it in the handout, only refer to it if the client has said they want to scale up and they're interested in manufacture. Which takes us to the end of the new sections of the FDS. Remember, they are predominantly things you have to research, and you have to get the most authoritative research that you can find. Thanks very much. See you next week.